All right, moving right along. Here we are, 1.4. Let's start with number 11. It says given f of x is x cubed minus 2x and g of x is square root of x plus 1 over 1. Find f of 0, g of 0, f of negative 1, g of 1, negative 1. Right, those are pretty easy. Let's do that right on the side here. Actually, let's take a moment to shrink that down first. That's kind of taking up all the space here. Okay, so number 11. What was that? Number 11. F of 0 first. So f of x was right here, right? X cubed minus 2x. So this is going to be 0 cubed minus 2 times 0, which is 0. Easy. That was easy. Okay, g of 0. G of 0 is, okay, it's g of x is this guy. Square root of x plus 1, so it's going to be square root of 0 plus 1. You just plug in the 0 wherever you see an x, right? Which is square root of 1 over 1, which is just 1 over 1, which is just 1. Now, normally I don't like to work horizontally like I'm doing right now. I don't actually advise that. I'm just doing that to kind of save space. So that's really don't. This is a classic case of don't do what I'm doing. So I'm going to stop doing that. F of a negative 1 is... Stop changing to eraser. F of negative 1 is negative 1 cubed minus 2 times negative 1. I suggest keeping the parentheses so that you don't mix up a sign. Negative 1 cubed is negative 1. And negative 2 times negative 1 is positive 2. Negative 1 plus 2 is 1. So there you go. Negative 1 plus 2, 1. Yeah, that's correct. Let's box our answers here. Okay, now for g of negative 1. What does g do? It takes the square root of whatever you input it, plus 1, and the bottom divide by 1. I don't know why it even says divide by 1. It's not even anything. Not even changing anything. Okay, anyway, don't go horizontal. Negative 1 plus 1 is 0, so I got the square root of 0 on the top, divided by 1. Square root of 0 is just 0. That's 0 over 1, which is just 0. So g of negative 1 is 0. Okay, easy. Delete. Oh, no. Delete. All right, one down, guys. 3 more to go for this section. Okay. So number 12. Determine whether the equation xy equals to negative 1 defines y and y as a function of x or not without graphing. Okay, so before we, and then x is to graph in the next part. But let's do without graphing first. So we're trying to figure out if this is a function of x. xy equals to negative 1. So how do you determine something's a function of x without graphing? So you just want to make sure that whatever I plug in for x, I don't have repeated values of x that give me the same. Wait, am I saying this right? I think it has to pass the visually has to pass a vertical line test, right? It means I shouldn't have more than one y value for a single x value. Yeah. So I shouldn't have a single x value with duplicate y values. Okay, so first thing I like to do is just solve for y. So this is going to be y is equal to negative 1 over x. Oh, I see. So this is a familiar friend, right? 1 over x type with a little reflection going on. All right. Now, whatever I plug in for x, is there any instance where I plug in something for x and it gives me 2 different y's? The answer is no, right? No. There's no instance where a single x is input. Gives two different y's. Two or more different y's. Y values. Why don't you write? Okay, there you go. Okay, so what does that mean? Yes, the function. So yes, y is a function of x. All right, so that's part A. Now part B says to sketch and then confirm with the vertical line test. So okay, this is good because 1 over x is a faithful friend of ours. Okay, here's x, here's 1. Remember 1 over x, the original, is like something like this, right? But what we have here is a negative of that. So then it's going to look almost the same, except it's going to be just reversed. By reversed, I mean it's going to be flipped. So it's going to look like this, flipped over the x-axis. Something like that. So that is gone. The red one is the final result. Now looking at this thing, does it pass the vertical line test? Yes, it does. Yes, it does. So no matter where I draw a vertical line, it's not going to cross through more than one time. Oops, missed. Oh, okay. You know, it looked like I crossed me more than once, but that's just because my picture is bad. Okay, it's not because it's actually failing the vertical line test. Okay, so there you go. That's part B. Confirms the answer. Yes, we got a function there, and of course it's a function. 1 over x. We know that guy, right? That's one of our friends from a later section where we had that library of functions. Great section. Beautiful section. 13. Find the domain and range of the function. Fx equals 1 over x minus 9. Okay. So first by inspection here. What could possibly go wrong here? Only one thing could go wrong. There's no square roots involved. No other things where I wouldn't have anything that's not defined, except for one spot, right? When x is 9, then I'm dividing by 0, right? So basically the domain is x cannot be 0, but we like to write that in interval notation. So the domain is everything negative infinity up until you hit. Oh, I'm sorry. I don't know why I wrote 0, guys. See, this is how I end up making these careless errors, and I have to write a correction letter to you later. This is supposed to be 9. This is supposed to be 9. The bottom I don't want to be 0, yeah? So 9 union with 9 to positive infinity. So that's the domain. That's the domain. Okay, now what's the range? What's the range? All right, so that's the domain. I tell you what, guys, we can actually sketch this. Because again, this is our friend, right? 1 over x. Except what's happening here is you're subtracting 9 close to the x value before you take the 1 over it. So that's a translation. 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like the new center. So we've got that asymptote right there. So the graph is going to look something like this. Now, looking at the graph helps us to visualize what's happening more easily here. In terms of the range, I basically have everything. The only one thing that I cannot get is I cannot get equal to 0. Right? I can go down as small as I want by making this as small as a fraction as I want. And I can go up forever by making this same thing, but making this as small a fraction as I want, but make sure it's positive. Right? If I wanted to go down and make sure it's a small negative fraction in the bottom. So I get everything except for I can't quite hit 0. That's the only thing. So the range is going to be negative infinity to 0, union from 0 to positive infinity. That's the main range. That was number 13 we just did. Yeah, that was number 13. Sorry, I forgot to label the number earlier. bad. Okay, last question. My bad, I'm not doing it again. Last question, number 14. Oh yeah, it's just a visual inspection type. Find the domain and range of the function. Then you evaluate f of 0. Okay. So domain first. Zoom in here. Domain first. Domain is all the possible x values I could have, right? It's looking. X values could be anything to the left. Here it looks like I might have a potential issue, but it's okay. It's covered by that point there. It keeps going, and then right here I have a potential issue right in the center, right? Well, not center, but that's at the point where x is 3. But that's covered by this point here. So that means, in terms of domain, everything is accounted for. The domain is negative infinity to positive infinity. Everything, the x could be anything at all. Now what about the range? I don't know why I started with that. Okay, now I'm going from the bottom to the top, or going up and down. Here's a cool idea, guys. So when you're checking range, what you're doing is you think of this line, just going upwards like this. If it's any time I see a gap as I go up, that's going to be a gap in the range. So going up, gap right there, right there. So there is a gap right there at y is equal to 2. So y could not be 2, that means, yeah. Oops. What is happening here? Sorry guys. I'm trying to, no, I'm not trying to select you. I'm just trying to select you. Okay, keep going. Okay, so that was the first issue. Then it looks like right here there might be an issue, but everything is covered on the left. Like this gap here is covered as this pink arrow goes further to the left. Except it's right here, the exact spot here, this horizontal asymptote. There's a potential for a gap, but it's okay because it's covered by that point right there, 0,3. It's a solid dot that covers the one hole I had. So that's covered. Everything above that is also covered, also possible. So then I go upwards forever and no other issue. So the only issue was right here, that little hole that we had when y was equal to, what is it? 2. So 2. So basically the range is everything except for 2. So I'm going to stop at 2, exclude it, and then continue onwards. All right? That's it for domain and range. Now, finally, evaluation f of 0, f of 2, f of 3. That's easy. F of 0, when x is 0, what's the value output? It's 3. So 3, just by inspection, yeah? You can just solve these by inspection. F of 2, where's 2? So here's x is equal to 2. At that point, I'm at 0. And then lastly, f of 3. So when x is 3, right here, I'm at that single point, 0. So I'm again at 0. And that, there we go. So 1.4 done, guys.